Okay, grade 8. This is your 6.6. This is your last chapter in the MathLinks 8 chapter on fractions. This is your order of operations chapter. So in the show you know, this is on 6.6. We have 3 questions, all dealing with order of operations. The first one says 7 times a half minus 2 divided by 3/5. And the context of this particular question is fairly difficult to come up with a real reason why we would ever do this in the real world. But it's just basically saying that when you're given multiple operations, do you know which to simplify first and how to simplify them? So the first thing we're going to do is we realize we have 3 operations. We have a multiplication, we have a subtraction, and we have a division. Now BeDMAS actually has 3 steps. It has brackets. The E we don't learn in grade 8 because, well, we do in circle, the area of a circle, but we don't use E for exponents. We have the second step, which is all of your division and multiplication in the order they appear from left to right. And our final step is to do all of the addition and subtraction in how they appear from left to right. So in this particular question, a lot of people think we should do the division first. And the reason why they think that is because D comes before M in BeDMAS, but that's not true. Division and multiplication is one step, and we simplify all of the division and multiplication as we read the sentence from left to right. And the first division or multiplication I see is 7 times a half. Now, if I want to use an algorithm, so when I think about 7, I really want to think about 7 as being 7 over 1, if I want to just be consistent with how I'm going to solve it, and multiply it by a half. And once I see it like this, I know that the process I need to use to get the answer is to multiply my numerators together, which is 7 times 1, which is 7, and 1 times 2, which is 2. So the product of 7 times a half is 7 halves. Or if I had a half pizza and I had 7 of them, I would have 7 halves, or 3 1/2. I'm going to keep it improper. I'm not going to change it to mixed. I'm just going to bring down the rest of my expression. Once you get good at it, you'll realize you can do your division too and bring down the subtraction, but we won't get there yet. So 7, oh, I'm not going to do that yet either, sorry. So what we're going to do next is our division. So 2 divided by 3/5. Again, I want to think of whole numbers. Every time I see a whole number, I want to think of it over 1. I want to change my division to multiplication every time I see division. And whatever the second fraction is, I want to use the reciprocal. So in this case, 3/5 is going to become 5/3. Now I'm simply going to multiply the numerators. Let's see if I can scroll this down a bit here. Multiply my numerators to get 10, multiply my denominators to get 3, and I get 10/3. So this 7 halves takeaway comes right down there. So 7 halves takeaway 10/3 is what this problem, this becomes 7 halves, this becomes 10/3. Now I'm simply going to subtract them from each other. So when I do that, there we go. Find your common denominator when you subtract fractions. In this case, 2 and 3 will become 6. The equivalent fraction to 7 halves that has a denominator of 6 will be 21/6. The equivalent fraction to 10/3 that has a denominator of 6 will be 26. So 21/6 take away 26 is 1/6, and that's your answer for the first question. Okay. A lot of people get confused because they're starting to confuse algorithms with, do I keep the 6 denominator? Do I add them? Do I subtract them? Is my denominator 0? No. When you have adding and subtracting of fractions, you really just got to keep it simple. I have 21/6. I'm taking away 26. That would mean I have 1/6 left over. Okay. The second question is 3 halves divided by the sum of a half and a quarter divided by 3/4. So in this one, I actually have a bracket. So the first thing I'm going to simplify is what's in the brackets. So 3 halves divided by, and I can actually do this mentally. A half plus a quarter is actually 3/4. But if you can't do that mentally, you've got to find your common denominator. 1/2 is actually 2/4. 2/4 plus 1/4 is 3/4. So the sum of those two in the brackets is going to become 3/4. And now I'm left with just a division operation and a division operation. So I'm going to do my first division. The rule is keep your first fraction, change to multiplication, and use the reciprocal. Okay. Now for this one, if you can cross reduce, you should. Now if you're not comfortable with cross reduction, you don't have to. If you don't cross reduce, you get 12/6, which I think most of us know is 2. But if you do cross reduce, I'll use a red marker here, pretend the 4 was over the 2, because if we've swapped those numerators and if 4 was over the 2, it would be 2 over 1. And if the 3 was over the 3, that would be 1 over 1. And when we multiply the numerators now, we would have 1 times 2, which is 2, over 1 times 1, which is 1. And I'm actually going to keep it as 2 over 1. So the product of 3 halves times 4 thirds is actually 2. And then I bring down the rest of it, because I haven't done this yet. Divide by 3/4. I have one division left, so keep your first fraction, change the multiplication, and use the reciprocal. When I multiply this all out, I will get, oh, son of a goat herder. Bring this over here. There we go. Oh, I even got the wrong page now. Where am I? Here I am. Bring this up here. Bring this down here. Multiply your numerators, you get 8. Multiply your denominators, you get 3. 8 thirds is really 2, which would be 6 thirds, and 2 thirds left over. Your last show you know is 2 1/4 take away a half times 3/4 take away an eighth. So we do have a bracket, so I'm going to simplify that first. Use your common denominator of 8. 3/4 is really 6 eighths. 6 eighths take away 1/8 is 5 eighths. All right, so when I simplify that bracket, I get 5 eighths. So now I have 2 1/4 take away a half multiplied by 5 eighths. Now a lot of people get confused here because they think now they should do just the subtraction. But as you see here, this is a multiplication. So I have to do that first. So I'm just going to write 2 1/2 take away. And the product of these two is going to be 5/16. If I multiply my numerators, 1 times 5 is 5, 2 times 8 is 16. And I get 5/16. Now I'm dealing with one last operation, which is subtraction, and I have a mixed fraction. Now some people like to keep the whole number there and just do a half take away 5/16. I like to just keep it all simple. And I say if you have a mixed fraction, just change it to improper. So this is the same question. And now it just makes how you're going to solve it easier, because I'm going to use a common denominator of 16. What fraction is equivalent to 5 halves that has a denominator of 18? It is 40/16. Now I have 40/16, and I take away 5/16. I would have 35/16 left in total, which as a mixed fraction would be 2. That's 32/16, and 3/16 left over. Okay. The second set of show you knows. It says Ron earns $15 an hour as a security guard. That's not bad. For time worked above 35 hours a week, he earns a time and a third. Time and a third. So time and a third basically means he gets his $15 plus he gets a third of an hour more. So whatever he would make in a third of an hour, which would be $5 actually, he would get that more. So how much does Ron earn for working a 41-hour week? Well, this is interesting. So it's actually an order of operations question. So he gets $15 times the first 35 hours he works. Plus, he would get a different rate for the next 6 hours. Because he works 41 hours, and everything above 35 hours is overtime, he's going to get 6 hours of overtime. Okay? Now, how much does he make for overtime? He makes $15 multiplied by 1 1/3. That's his rate for, instead of multiplying it by 1, he gets 1 1/3 dollars per hour multiplied by the number of hours he worked, which is 6. Okay? So this is, right here, this is how much he makes per hour for overtime. Because he makes 1 1/3 times his 15 regular hours of $15 an hour. And the reason why the 6 is here is because that's how many overtime hours he's working. That's 41, take away the 35 hours that he works in a regular week. Okay. So once we see this as an order of operations question, we realize that 15 times 35, I'll use a calculator for this, 15 times $35, he makes $525 in regular hours. Plus, if you take 15 and you multiply it by 1 1/3, that would be 15 over 1 multiplied by, well, 1 1/3 is really 4 thirds. If I cross-reduce that, 15 over 3. If I think about 15 over 3, I'll do it up here. That would reduce down to 5 over 1, which would mean that if he makes 5 1/3 hours overtime, he makes actually $20 an hour for every overtime hour he works, because that third of an hour is actually $5 more. And he did 6 of those hours. So he has 525, and then he has $120 in overtime wages. Okay? This is his overtime here. So what does this mean? Well, if I take his regular and I add his overtime, I would have $645 in total for the week. And that's the answer. He makes $645 for the week. Okay? So if we go back and look at that, this is kind of interesting because a lot of people have never thought about BeDMAS as being actually used for something purposeful. And there's a good example of how that expression represents Ron's earnings for the week. Okay. All right, if you like this video, make sure you slap that like button, smash that like button, and don't forget, for every new subscriber, I will give a dum-dum to the breakfast program here at school. Is it not a good thing? Oh, maybe it's not.